we continue our workshop with a lecture on global scenarios for nuclear energy and role of the innovative nuclear energy systems, which will be delivered by Dr. BYCHKOV, who is working now in the IAEA as senior senior expert in the INPRO section. Alexander, please.
Good morning, dear colleagues, and good morning, good evening, maybe good afternoon for colleagues who join virtually. I will give you 4 lectures during last 3 days, and all these 4 lectures had a lot of cross-cutting points due to now I'm working in INPRO project, and all these lectures will be connected with this project. It is one of activity of the agency, but my second lecture will be dedicated to this project. Initially, I would like to make a brief view to current status of nuclear power and to make some key remarks relating to role of nuclear power, and would like to share some approaches and ideas to consider future scenarios of nuclear energy development in the world. So, first of all, currently it's all lectures who talks about future should take into account current United Nations approach to consider our future from point of view of sustainable development goals. Of course, the understanding of what is sustainability and the effect on sustainability from different point of view, it is so special branch of current human science and some other things. But take into account role of nuclear power, we should underline that some lines directly connected with nuclear powers. First of energy. I will not discuss about others, but energy. Of course, I think you know that the energy production directly affect to human development. And here you can see traditional picture, it's human development indexes and consumption of energy in any form per capita in countries. And so you see this tendency. Take into account that now more than more than 1 billion people have no access to electricity, and regular service-related electricity. Of course, we in the world should work in direction of improving of this situation. And current tendency in our century and the end of 20th century, first of all, growth of energy demand. Yes, change of energy mix.
Please mute your microphones.
Oh, it's maybe mine? Not.
It's just this that it's. Let's take the badge away, if you don't mind.
Okay, oh, sure.
That was banging out against the microphone. Will be fine.
Okay.
Thank you.
And we have high dependence on fossil fuel. I will not explain this picture in detail. And here you can see the tendency during last 40 years. Truly speaking, it is the period of my scientific, technological, and administrative and diplomatic life. namely the same period. I start work from 1982. But in this period, we had, in the world, we have, first of all, growth of generation of electricity more than in twice. Growth of so-named renewable sources share. You see growth of coal, growth of gas, partial growth of nuclear, but later some stabilization, and growth of hydropower production due to now the world has a lot of interesting technology for effective using of these sources. So in any case, the role of nuclear power is very important here. Some evaluations made by International Energy Agency, not our International Atomic Energy Agency, describe a picture that demonstrate that near for 30 or 40 years we will have more high portion of renewables. No, truly speaking, I'm not believe in this system due to dispersed sources of electricity. Is very high challenge to practical security of these sources. I know that in some countries, relation to properties, it's not so similar as, for example, in Austria, where it's possible to have more than 200 small hydropower plants without any defense, no, very small defense, without any guards who try to save this equipment. But in some countries, I know if last soldier will left from site, next morning this site will be empty. It's unfortunately it's necessary to work with society too. So, but in any case, the part of nuclear in these projections also very high. Why? First of all, we have a very important point from point of view of greenhouse gas emission. Nuclear is one of best technology. And it really has competition with offshore wind and hydropower. And what we have now, so truly speaking, we have tendency to increase the production of electricity by energy by nuclear power, but what we have now, December's last 2 months were very important months from point of view of our statistic. Till September, in our statistic, we took into account around of 20 Japanese reactors as reactors which should be considered as operated but in situation of shutdown, but not full shutdown. But now agency received official information from Japan. Now we have on 20 reactors less in the world. And you can see that currently the main part of reactors locates in North America, Western Europe, Far East, Korea, China, and Japan, and Eastern Europe, including Russia, and a few reactors in Africa, Latin America, and other part of the Asia. No reactors in Australia and Oceania too. So, simple statistic. Of course, till now, the key recordsman is US. Slowly they drop a number of reactors. 5 years ago, 8 years ago they had 100, but now 92. France stable, has very good demonstration of stability of operation of nuclear power plant, in spite of some specific economical and political situation, but very stable. China, very strong growth. Russia, relatively stable situation, closing of some reactors, construction of new. South Korea also has a very good picture. India, continue growth. Canada, stable situation, but Japan, unfortunately, dropped from 52, I think it was maximum, yes, 52 reactors under operation, but now it's only 17. Construction, of course, China is recordsman, India, Russia, Turkey, South Korea, more than 2 reactors under construction, and we have long list of countries that which have 2 or 1 reactors under construction, take into account USA, UK, as developed countries, or Egypt, Bangladesh, as developing countries. So, agency, International Atomic Energy Agency, where I serve, serving every year, every August is publishing some projections for capacity of nuclear power for next period. This year, is data published this year, we have 2 scenarios, low and high. In case of low scenarios, during next 30 years, it was expected to have approximately the similar capacity of nuclear powers. Small reactors, old reactors will close, will shut down, permanently shut down, and new reactors will construct. But in high level, it's growth more than in 2 times. These projections change a little bit every year. For example, before Fukushima, we had very high projections after tsunami, nuclear renaissance, but now it's more realistic scenarios. And only few words about key points of nuclear. First of all, capital cost for in US dollar for established kilowatt hours. Nuclear is not cheaper, but it's not so expensive in comparison of nuclear power plants with coal, where carbon dioxide that have has carbon dioxide capture systems. But take into account tendency in some technologies. Maybe in future this line will move to less expensive part, but nuclear will have the similar indexes related capital cost. But in comparison of all other sources, nuclear power reactors now can work more than 60 years. So, of course, it is not easy to compare. Construction period, it's also not very good part of nuclear technology today. Unfortunately, we have not good experience in some countries, leading countries in construction. Here is no Russia, due to Russia had very specific period. For example, very famous reactor BN 800s that now operate with MOX fuel truly had construction period more than 30 years. But it was very long period of this site stayed without any activities. So, also very important point, the distribution of cost of some sources from point of view of capital. operation and fuel. Of course, nuclear here has a very interesting situation, position. The part of uranium is very, very low, and all expenses for fuel is also not very high. It's as usual 15%, but for some reactors 10 or between 10 and 15. So, and of course now, and not now, it's during, maybe take into account history from 1973, from first oil crisis, the effect of doubling of fuel price for nuclear is much low in comparison of coal and natural gas. If we will have situation with increasing price for uranium in twice, we will have very, very, very small effect on cost of kilowatt hour in comparison of coal or natural gas. So key drivers, it's diversification of supply of energy, situation with greenhouse gas and other air pollution, energy security. It's also a very important point. Take into account that nuclear power reactors could work very, very long period in comparison of other sources. Predictability of generation cost, stable and reliable base load supply, and nuclear has very strong socio-economic benefits, not only from point of view of stable supply of electricity, but from point of view of growth of, well, first of all, education and so on, so on, so on. For coal plants, you need approximately 10 good educated engineers. For nuclear power plant, you should have 150 good educated nuclear engineers. So, and education system, culture system of the state also need some adopting for high level technology. So, now about scenarios. Of course, I underline that to discuss about scenarios for nuclear power and to work in area of prediction of some technology, it is not so maybe not so strong science, due to every year, every decades, you can receive in the world some new challenges, some new data, and maybe some new technologies. For example, if compare 70s, 60s, when nuclear power was established as branch of industrial branch, nobody had no any dreams about current informational revolution and revolution in area of system controls and some other things. But from other hand, all predictions are necessary for understanding what we can do in observed period that can be observed. So here I include some scenarios, ideas and developments from point of view of to my professional line. First of all, nuclear fuel cycle. It's my key line of expertise is nuclear fuel cycle, and from point of INPRO project. So some words, I think you know this picture. Maybe I'm third or fourth lecturers who remind this picture, but here I would like to underline that new generation of reactors, innovative reactors, have potential for significant improvement to make very strong contribution for sustainable development goals. So it's relation between current political and social needs. Of course, here, not generation 4 considered reactor system, but I think we should consider not only reactors, new reactors, different capacity reactors. We need to consider fuel resources from point of view of diversification of supply, from point of view of new technology, take into account some specific systems. We should take into account inventory of spent nuclear fuel. We should take into account a multinational approach to nuclear fuel cycle, and of course the problem of high-level waste. It is one of problem in the mind of people, and of course to work in area of optimization of this system. From point of view of relation between reactor systems and nuclear fuel cycle, we can consider 3 scenarios, and one of our colleagues who left agency last year suggested to consider, for example, fuel cycle activity from point of view of 3 scenarios. Those scenarios, it is close to low projections of agency, low case of projections of agency, nuclear power and fuel cycle options are implemented as they are today. Next scenarios, it's prognosis for significant increase of nuclear power, take into account multi-recycling and some other things. And third, negative scenarios, that nuclear power is gradually phased out during next 30 or 50 years. For first case, we need improved reactor design, we need advanced fuel, maybe we need innovative reactors also for some part of this system. Enhancement of fuel cycle facility safety, that's also necessary, take into account that they will affect on final disposal systems. It's necessary to organize a system for final disposal of spent fuel and high-level waste, and some other international and political aspects. But innovations has a role here, but mainly for extension of life cycle of nuclear power and construction of new reactors. Second scenarios, of course, request a lot of new innovations, not only advanced reactors, but innovative reactors too. Expansion of into non-nuclear market, it's also very important due to some nuclear sources can work in some in different systems. I know you have lectures related to this. It's necessary to have fully closed fuel cycle and to work to direction of minimization of burden from point of view of waste, broadly speaking, work in transmutation. And really, here in these scenarios, we can speak about sustainability, take into account this historical expected historical trend of energy demands and some other related things. And third, of course, here it was not good, but in any case, people should continue university courses. We should continue work in area of improvement of safety. And in any case, we need a lot of efforts to make nuclear power relatively effective and safe. So, from INPRA project, I will explain about this project a little bit later, but here I would like to demonstrate some exercises of experts from different countries for in area of consideration of future architecture of nuclear power and fuel cycle. We have so named area or task global scenarios where the agency through INPRA project work in area of global vision of sustainable nuclear energy development in current century and beyond. And it's a very important point, these exercises, these studies, collaborative studies, generate some information, some instruments, tools for member states for further formulating national strategy for enhancing nuclear energy sustainability. So we had a steps activity, for example, in the first period of this project, INPRA made some analysis of nuclear technology for further development. Here I would like to say some very important historical words. Agency, International Atomic Energy Agency, during very long period had no specific activity related complex consideration of nuclear power and fuel cycle. We had fast reactors activity in area of uranium mining, activity in area of spent fuel management, some mainly collection of information. And only some conferences organized by agency could be considered as places for sharing of view about complex future, complex vision to future of nuclear power. INPRA was the first step to organize this study on basis of, first of all, in the frame of the agency, and second, on the basis of current available instruments that can help to consider future of nuclear power. Take into account some limitations in activity of the agency, for example, activity in area of enrichment, current reprocessing is not so, so supported by many member states. So we start from analysis of situation for future. It was activity close to generation 4 activity. For example, we have also some type of pyramids, low scenarios, moderated scenarios, and high scenarios. For example, here it's maximum innovative systems, fast reactors. Here, fast reactors, some modular reactors, SMRs, and in high scenarios, of course, new systems take into account probable application of efficient thermonuclear reactors. So we had a very interesting study where first time in agency the term closed fuel cycle was put on before reactor system. Closed fuel cycle, nuclear fuel cycle with fast reactors. In nuclear community, we had a number of schools. For example, in Dimitrovgrad, we also considered systems also from point of view of fuel cycle and this advanced. But in the agency, it was first studies. Colleagues from many states considered different sources. For example, role of thorium to supplement fuel in future nuclear energy, take into account different scenarios. And finally, the agency understood that member states needs to consider some transition scenarios from current situation in nuclear power and for newcomer too also, to new sustainable nuclear energy systems. First of all, member states need supporting decision-making process, and this decision-making process should be organized from point of view of harmonization of national political, technical, institutional aspects and access to technology. And some member states suggested to start modeling of some regional and global trends for nuclear power supply in some regions. It's not only states' activity. Sorry. Okay, and in the frame of INPRA, we fulfilled two collaborative projects. One project, it's a project with title of GAINS, abbreviation GAINS. It's Global Architecture of Innovative Nuclear Energy System based on thermal and fast reactors, including closed fuel cycle. And next, followed project has also a very bright title, Synergies, Synergetic Nuclear Energy Regional Group, Interaction Evaluated for Sustainability. Briefly about this project, if you have interest, you can open some slides and read later. But here I would like to underline that some issues were taken into account as key issues. For example, accumulation of spent fuel in the world that can create some burden for next generations. Non-effective use of natural material resources for reactors with it's light water reactors, heavy water reactors, so on. Presence of some materials that can be considered as very dangerous from point of view of proliferation. But from other hand, the world, nuclear world, key nuclear countries had and have and will have very big investment to research and development related to innovative reactors. And from other hand, of course, we should take into account risks related to uranium enrichment and reprocessing of spent fuel. Colleagues considered different scenarios. For example, here, GAINS considered four name architectural systems. It is homogeneous world as business as usual, light water reactors, heavy water reactors, and little bit fast reactors. Heterogeneous world, I will explain a little bit later. And a new system for transportation of minor actinides, take into account not only current fleet and current innovations and future systems, type of IDS. Yesterday we saw a number of studies related to IDS in the poster session, and molten salt reactors too. And of course, one of steps is thorium. Colleagues consider from, I remember it's around 18 countries participated in this study. Some countries more active, some not so active, but they consider it different type of fuel cycle, taken using of some modeling system, try to understand what we will have on the final stage. And one of key conclusion of this study is not so technical. This conclusion is really more connected to architecture of future fuel cycle and nuclear power systems. You see, truly speaking, current heterogeneous world could be split on three groups. One group of the states, for example, France, Russia, tendency China, tendency in India, former strategy of Japan. The state has different type of reactors and system for production, management, production of fuel, management with spent fuel, and so on, so on, so on. Take into account that this state could work in area of transportation of waste and reduction of radiotoxicity and so on. Nuclear group, second group, they have nuclear power plants, they have system for production of fresh fuel, and some repository. It's here, for example, Switzerland, Finland, Canada, it's a lot of, and third countries that will have mainly nuclear power plants for operation. As usual, they can buy nuclear fuel outside, or maybe have some limited system for production of fuel and place for storage of fuel, not disposal. And finally, of course, the colleagues who worked on these scenarios recommended. Now it seems it's very simple to organize some name homogeneous world where all three type of countries work together. This state can take responsibility for transmutation, for disposition, not disposal, using of plutonium and actinides. This state can work by contract, by other intergovernmental system to serve all other countries. Of course, this tendency discussed in many other platforms take into account that we need necessary to work to create some international service for spent fuel management. But unfortunately, currently we have only two active states who really works in this area. It's France and Russia. Oh, some, maybe 10 years ago, we had UK that also organized some overseas contracts, but now they are closed the programs. So it's some elements from this study. And next study, synergies, consider it more complicated line of technologies related fuel cycle and reactor system. Oh, it's one of demonstration, one of picture demonstrated technology connection between current reactors, current technological system for fuel production with advanced system and innovative system, take into account necessity to dispose minor actinides too. All type of available closed fuel cycle were considered, and this study was more thick. It's, I remember it is around 500 pages. But the next options were declared that synergies in the context of nuclear energy are those actions that a country or group of countries may undertake, facilitate the development of the nuclear energy system with enhanced sustainability. It's a very specific system. Enhanced sustainability may be achieved via innovations. It's one line, and increasing collaboration among technology holder and technology users. So it was not so new conclusion, but it was a conclusion after very precise consideration of different technological scenarios. So now, close to last words of my first lecture, I would like to underline what drivers we have in area of international cooperation and collaboration for establishing sustainable nuclear power with fuel cycle. Well, first of all, economic competitiveness of nuclear energy, and technology user countries have chance to receive very strong and important sources of electricity. Second, technology developer countries also have chance to monetizing, to use the big research and development program for implementation of innovative nuclear reactors. Here we have really synergetic effect of this cooperation, not only simple increasing, it's really we can have some effect of resonance if, truly speaking, we can organize similar world, similar nuclear world. And of course, it's additional motivation technology holders to continue their studies. And I can underline that we have good commercial practice in this area. For example, French practice take into account the service for European countries. And for related Russia, it's maybe mainly past service related former so named socialist countries. It's also comprehensive service. Also some points here, in that case, in the world, we have very good chance to control plutonium inventories, and from other case to receive effect of minimization of high-level waste. From other hand, increasing of energy independence for many member states and preservation of natural resources. So it's key points and some impediments. First of all, national laws, insufficiency of institutional procedures for nuclear fuel and high-level transactions between countries. Problem, also legal problem with radioactive wastes, and it's maybe not so strong underlined, but it's some political and social situation around nuclear power. So these studies, last study, Synergy, was published in 2018. These studies recommended some actions toward this enhanced nuclear energy sustainability. It's a very complicated term, enhanced sustainability, sustainability enhanced. So, in any case, near and medium-term actions are needed to continue, ensure and improve long-term sustainability of global nuclear energy. Use of this technology in synergetic activity is very important for global advances of nuclear. Subject-related spent fuel inventory, and here also we need to expand these systems. And of course, we need to work with public acceptance in this area. So, it's end of my, so last slide, yes, last slide. Sorry. Major finding of these two projects. So we consider in INPRA, and not only INPRA, that really it was a very good attempt to consider scenarios of future energy. And also a very important point connected to cooperation, namely potential benefits of this collaboration is minimization of infrastructure efforts for individual countries' nuclear energy systems, if we will have some homogeneous nuclear world. It's very important. Suggesting sound solutions for spent nuclear fuel utilization and disposal. It will give effect to public acceptance too. enable optimum use of available resources, using of fast reactors and other system, of course, and future using of thorium. Minimizing cost owing to economy of scale and other factors. So it is one of the tendency, and take into account other activity of the agency, we have and will have discussion and some movement to these directions. It's my first lecture. I have another, maybe. Thank you.
Okay, thank you, Alexander. Would you like to go first the questions to this, or you go to the in-pro activities now? Up to you.
What you think? Due to
So do we have any quick questions to Alexander?
Yes, maybe.
Please.
When I will
use the
drink
microphone.
water.
Use this microphone.
Thanks for your lecture, Dr. BYCHKOV. I have a question about the part of collaboration between countries, because we know that nuclear technology is a very sensitive technology in most cases. And for example, in Brazil, that we had to develop our own uranium enrichment processes that would be not transferred by other countries. And how do you think that we can enhance the collaboration in the sense of being open to transfer the technologies?
Here it's very important point of mainly in synergy, where is some country, so name technology holders cannot transmit this technology to some other countries. They can organize service through this technology. For example, simple approaches for using of plutonium. For example, the technology holder can construct and put into operation new reactors in some new countries. But if in future these technology holders can take back spent fuel for reprocessing and using of plutonium in technology holders territory, it's one option. Or maybe sending of MOX fuel, or new idea of my Russian colleagues, remix fuel back to these countries. In that case, any technology related extraction of plutonium, separation of plutonium, will be behind of new user of this technology. Of course, if we will suggest some innovative technology to newcomer countries, it's also necessary to consider these aspects. But from other hand, we should take into account some expected advances of technology. For example, so some interesting discussion inside of IFNEC. Some years ago, I suggested to consider safeguardability and security, long-term safeguardability of disposal place for spent nuclear fuel. For example, after 100 years disposal, you will have very good quality plutonium. But maybe in future, somebody will have technology for horizontal drilling, for example, 50 kilometers and to extract in city some plutonium. It's possible. But from other hand, maybe in this period we can find technology when we can ability to account any grams of plutonium in high-enriched uranium in any load. So we cannot speak about realization of long-term point scenario of safeguards and security. Sorry, it's some subject for consideration of export of technologies.
Because I see, like in the European Union, you have the development of, for example, the lead cool technologies. In each country, you have a facility that develops a part of the technology. But I don't know if the communication is very open between, for example, the European Union and in South America or even Russia, you know, so as we could all be developing the same technology going forward instead of competing against each other, and in a sense, you know, because it's a sensitive information that we don't want to share. I don't know.
No, from point of view of, no, first of all, additional to technology cooperation, we have so named institutional or legal aspects, and I will explain on Friday some nuances related this part of innovations. It's also important. Truly speaking, currently we have a lot of instruments in the world for control and regulation of export of sensitive technologies. Of course, they mainly, not fully, mainly based on some political decisions and some international laws. But in some technological line, it's possible to use so name technical system for limitation of using of some technologies. But here it's not predictable.
Yes. Okay. Yes, I would like to add something about collaboration. I don't know if there was a part of the answer. On the other side, for example, in the frame of sodium fast reactors, we have, I think, a lot of collaboration between, I would say, most of the partners involved in sodium fast reactors. It's clearly, for example, the case between France and the Russian Federation since a very long time. Before, during the Soviet Union, and more recently, of course, we have exchange possibilities of irradiation in BOR 60, exchange on technology and so on. Same with Japan, of course. We have a very close collaboration, particularly within the frame of Astrid. And we have the GIF frame for collaboration, the IMPRO, the IAEA activities, the OECD. So there are a lot of places where we can exchange and share and develop sometimes some common programs, some common R&D, and so on.
Yes, and you're right that
But the fuel is a particular area.
it's too early for competition. It's time for cooperation now
Yes.
in the field of the LFR and other fast
There are not
reactors.
so many commercial products.
In live water reactors, we have very big competition.
I'm talking about fast reactors and lead. It was a question about lead-cooled fast reactors.
One more question. Vladimir.
I deduct from your time.
Okay. Thank you for your presentation. I continue the Umezo question. I'm a similar question. For example, we talk about the nuclear energy system for future. We have many designs, many ideas for future of the energy. Without the collaboration, the future of the energy is a very dark, I think. Because, for example, for the licensing of the nuclear power plant, every country have its own ways and follow their own ways. It would be very difficult for that. We need collaboration for the future of the energy for the world. It's very important. And I think we need to committees to connect the in IAEA, for example, for a technological to follow the near replacement of the near technology for future, I think.
Oh, but there's no questions. I understood there's more remarks. And truly speaking, in the energy world, in United Nations system, we had a lot of attempts. For example, when I served agency as Deputy Director General, I had very strong communication with so-named Sustainable Energy for All. It was initiative from Ban Ki-moon, previous General Secretary. And one of our colleagues in Vienna, Mr. Junkela, who led UNIDA, led later this Sustainable Energy for All office in Vienna. We had idea to establish a special post of his advisor on nuclear power, and we had a lot of discussions, preliminary, and unfortunately the board of governors of Sustainable Energy for All took decision that we will not touch nuclear due to our focus is on the developing countries. And his joke, we have three sources for underdeveloping countries: coal, coal, and coal. Due to, for real growth of, fast growth of electricity, in many countries it's possible to establish small or big coal factories. Unfortunately, now it's considered as relatively negative from point of view of climate and big world, but from point of view of every small countries where half of population have no access to electricity, it should be considered as big progress. But so it's different view, differences in views, differences in needs of states. We cannot take into account all aspects. But your remarks is very important here. Would you like to add something?
Yes, and ask you a question.
Ah, okay. So
Now about I think that in your slides there is not a slide maybe showing the impact of a new approach, for example, to see what is the impact of small reactors, modular or not, small reactors, to decarbonize some activities. For example, production of fertilizers use a lot of energy for hydrogen. You know that hydrogen comes from the natural gas, and the people, when they grow carrots and so on, they ignore that they are using, in fact, natural gas. Huh? Okay, this is the first point. Cement, steel, and so on, and so on. And small modular reactors could be maybe implemented in several countries without maybe the reprocessing plants. So major countries could reprocess. I think it's a good approach. So I think that my question was, because we see on your slide that in the future, even if we increase the nuclear, the total energy increases much more due to coal, gas, and oil energy. So it means that if we don't want, in particular the young people, roasted, okay, and without water and so on in the near future, I think that it's mandatory to increase, of course, nuclear. Maybe nuclear with small reactors in order to be more on the sites, close to industrial sites, to produce water, because energy is one problem, the water is another one, maybe very important also, very important, not maybe, very important. And for desalination and of course, with renewable energies, of course, a good future. So I think that the energy problem is maybe less, it's a problem of large reactors, but also is more, there is a necessity to check how we need to implement the nuclear energy, and maybe to have a more adequacy between the needs and the power. It's necessary to have maybe smaller reactors to adapt to many places, because some countries are very large, and so on and so on. I would like to know what is your position with small reactors and to decarbonize.
Maybe before you go, just to also to shorten, to comment.
I would like to
Alexander,
touch
let me add
problem.
to this question, and then you discuss. So, also your forecast was low and high. I mean, pessimistic and optimistic. This is like the same total installed capacity or double. And even if it's double, it will be less than in percentages as now in 2050, because the total energy, electricity production will be 2-3 times higher than now, okay? So, and of this, let's say we go to be 5 or 10% of the electricity production, how much of this part will be on SMRs from your predictions and to answer?
Good summary.
I had intention to touch this problem on Friday due to, from technological point of view, currently we have a lot of open doors for SMRs. But from point of view of economic, legal, security, safeguardability, spent nuclear fuel management, we have 5 closed doors. I will explain on Friday.
Okay, thank you. So please prepare as a good explanation for us.
So
So now let's go to another presentation by Dr. BYCHKOV on